Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on infinite series. Last time, we learned about sigma notation and how to find the partial sum of arithmetic and geometric progressions. Today, we will define divergence and convergence. We will see how infinite series can be divergent or convergent, and we will see how recurring decimals converge. If you are ready, students, we will begin. If you try to add the terms of an infinite sequence, you get an expression of the form A1 plus A2 plus A3 and so on through AN. This kind of sum is called an infinite series. It is denoted by the sigma notation as A1 plus A2 plus A3 and so on to AN equals the sum of AN, where n starting from 1 to infinity. Let us explore the concept of an infinite series by finding the nth partial sum Sn for this sequence. As we learned in our last lesson, Sn equals n over 2 times n plus 1 is the sum of the first n natural numbers. As n becomes larger and larger, Sn gets larger and larger. Since n increases indefinitely, Sn increases indefinitely. Expressed another way, as n tends to infinity, Sn tends to infinity. Therefore, the nth partial sum Sn is infinite. It is time for our first activity, students. Using what we have learned, try to find the nth partial sum of this series. You may get started now.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Welcome back, students. You can see that this sequence is different from the first example in that it is geometric. Sn equals G1 times 1 minus r to the power of n over 1 minus r. This is the formula for the partial sum of a geometric series. G1 equals 1 over 3 and r equals 1 over 3. Therefore, we must substitute the correct values. Sn equals 1 over 3 times 1 minus 1 over 3 to the power of n divided by 1 minus 1 over 3. When we simplify this fraction, it becomes 1 over 3 times 1 minus 1 over 3 to the power of n over 2 over 3. Let us write the expression as 1 over 3 times 1 minus 1 over 3 to the power of n times 3 over 2. Simplified, this becomes 1/2 times 1 minus 1 over 3 to the power of n. Therefore, this equals 1/2 minus 1/2 times 1 over 3 to the power of n. Therefore, as n approaches infinity, the value of 1 over 3 to the power of n becomes almost 0. So, Sn tends toward 1. In general, as n tends toward infinity, if the partial sum tends to a unique finite number s, then we say that the infinite series converges and the infinite sum is equal to s. If this is not the case, and the partial sum does not tend toward a unique finite number, the infinite series is said to diverge. The formal definition of convergence is as follows. Let an be a sequence and Sn be the nth partial sum such that as n tends to infinity, Sn tends to s, where s is a real finite number. Then we say the infinite series an converges and is written as the sum over n from 1 to infinity of an equals s. However, if such an s does not exist or is infinite, we say that the infinite series an diverges. Let us do another activity, students. Find the following sum assuming that the pattern continues as in the first few terms.
Students, let's get ready. Begin. Time's up! Let's get back to our lesson.
Hello, students. Recall that if Gn is a geometric series with common ratio r that is less than 1, then Sn equals G1 over 1 minus r minus G1 times r to the power of n over 1 minus r, which leaves G1 over 1 minus r. In that case, S infinity equals G1 over 1 minus r. For this equation, G1 is equal to 6 and the ratio is 1 over 3. When we substitute the correct values, our equation looks like this: 6 over 1 minus 1 over 3. This equals 6 over 2/3 or 9. It is possible to apply these principles to physical problems as well. For example, imagine that a ball is dropped from a height of 70 meters. In each bounce, it rebounds to 0.4 of the distance it fell. Students, try to find the maximum possible vertical distance that the ball could travel.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Did you do well with this problem, students? If we assume that the ball never comes to absolute rest, the total distance is expressed by the equation S equals 2 times h over 1 minus r minus h. This formula can be simplified to the form h times r plus 1 over 1 minus r. Each time the ball bounces, it travels 2/5 of the distance that it fell. When we substitute the correct values, our equation becomes 70 times 1 plus 2 over 5 divided by 1 minus 2 over 5. We simplify the fraction to 7 over 5 divided by 3 over 5, which equals 7 over 3, or 2 1/3. 70 times 2 1/3 equals 163 1/3 meters, which is our answer. That is all for today, students. Until next lesson, thank you, teacher. Thank you, students.